You see that?
One moment.
Yeah, it's a thing
Yes,
for me, Martin.
okay.
So there is, so I can hide this, but I can't see you when I'm sharing.
No, you cannot.
But you can see me.
Definitely. We can
Yes.
see you. Yes.
That's a very irritating thing because I can't see if you're bored.
Well, that's a problem. That's an issue we're facing for the whole. For the whole period, we're not lecturing.
Well, no. On some systems, you can see people as well. On what we use, Microsoft Teams, you can see one person at a time, and on Zoom, you can see quite a few people. Okay, so how do I stop sharing?
The same icon you used to share, I believe.
But all the icons have gone. Hang on.
So click the escape button.
Yeah, stop sharing.
Okay. I don't know if actually it's possible to. I don't know if it's possible for you to look at us as long as you're presenting, but I don't think so. And we have an additional issue here in Brazil that we cannot ask the people to open their camera. I don't know how to say, but
yeah. What you mean is that if people want to show themselves, they can, but you cannot demand that they do so.
Exactly. And what we usually do is to cut off our videos during the presentation of the speaker, and at the end of the presentation we have a period of time for questions and interaction with the speaker, and in that case the person asking the question usually opens his camera, and so you can talk with him or her directly. And that's it.
Okay. Fine.
One moment, I'm trying to. Okay, looks like. Let me just one quick moment. I will take my mobile phone to check if the streaming live is happening correctly or not.
Okay.
One moment.
So, Rodolfo, while Giordano's doing the checking, why don't you say a bit something in Brazilian to the audience?
Olá a todos, meu nome é Rodolfo, eu estou trabalhando com o professor Poliakoff aqui na Universidade de Nottingham. Eu estou como pós-doc aqui, eu fiz doutorado aí na UFRJ, no Instituto de Química. Então, só para mostrar que vocês têm possibilidades de vir para o país. Existem outras possibilidades também na indústria, o professor Poliakoff vai falar um pouco sobre. Se vocês tiverem qualquer dúvida ou querem saber qualquer coisa, eu estou à disposição. E bem-vindos todos ao seminário.
O seminário vai ser em inglês, tá?
Yeah, but people can ask questions in Brazilian if they wish, and Rodolfo will translate them.
I can help with the translation. Posso traduzir qualquer pergunta que vocês tenham também.
It's great to see you, Rodolfo.
Olá, João, tudo bem?
Tudo bem. Saudades suas.
Também.
How are you coping with the pandemic at the University of Nottingham?
Well, I think, well, on one level, we're not coping because I have been working from home for 18 months. But on another level, we have been quite successful, and in the chemistry department, as far as I'm aware, nobody has caught COVID through working in the labs. And there have been cases, but they have usually caught them while traveling or going to parties and things like that.
Yeah.
But it has been very disruptive, obviously.
Yeah. Here it's been a problem, and we managed to, of course, to lecture through the internet, but it's hardly the same thing. Yeah.
Well, the problem with lecturing from the internet is that people are much more serious. They never make jokes when lecturing by video, and which I find a bit boring.
Yes. The human interaction is important.
Yes, but for some things, like if you are working with a colleague to write a grant proposal or something like that, working interactively with a shared document is probably better than sitting in an office.
Yeah.
So there are positives and negatives.
There are definitely positives as well, because if it will not been for the pandemic, you would not have probably joined us for this seminar. So
Yeah.
this is one example.
Well, I mean, I think that is very positive, because I have given lectures in the last year in China, in Greece, in Ireland, in Russia. But on the other hand, we miss traveling. And I like Brazil, and the food is wonderful. It is better in Brazil than in any other country that I have visited, I think. So there are positives and negatives, but the journey is rather long.
Yes. It's definitely a huge leap to reach here.
And but the good thing is the hour difference is small. It is much worse going to China or Australia or somewhere like that.
Yeah. And another thing which is good for the seminar is that the difference in the time is not that much. I mean, 4 hours it's bearable. I wanted to ask someone from Japan and Australia to give a seminar as well, but I gave up because there was a 12-hour difference, so it would have been impossible. I mean.
Yeah, well, you might be able to get somebody to lecture at 10 at night. I mean, 10 at night in China, and to you at 10 in the morning. It depends how enthusiastic the speaker is.
You of course, yes, and it depends if I knew the speaker personally as well, if I could ask such an effort from him or her. So not all of the people, they have the good attitude you are showing us today, Professor.
Well, you don't know. I haven't really shown you yet. There is question. Adolfo, I wanted to ask you: are you in the little room in our A40 office? Or?
I'm in B3.
B3, yes. So it is only very recently that our group has been able to use offices. Up till that time, they have had to work either in the lab or go home. So I think you want to start the talk at 10 past, is that right?
10. Yes. But just 5 more minutes, just for the.
So I will leave everything attached. If you excuse me 1 minute, I will go.
Please.
And then I will come back.
Okay. E aí, Rodolfo, como tá sendo? Nottingham.
Tá sendo legal, uma experiência interessante começar um pós-doc no meio de uma pandemia. A transição foi complicada porque tem todo um sistema de protocolos para garantir que você não tenha contaminações. Por exemplo, as capelas aqui funcionam com exaustão máxima para garantir a renovação do ar nos laboratórios. Tem sistema de circulação interno que você só pode ter uma direção. Agora eles começaram a liberar, você não tem mais o sistema único, mas as capelas ainda funcionam. Alguns grupos têm protocolos específicos, mas em geral tá sendo legal. Tá dando para fazer bastante trabalho.
Você está trabalhando com o quê?
Química em fluxo. Fotoquímica em fluxo, para ser mais específico. Então, a gente está dentro de um grande projeto que é chamado Fotoeletron, que é um projeto para produzir química fina, farmacêuticos, agroquímicos, com alta eficiência e de forma sustentável.
Legal. Boa sorte.
Obrigado. E como é que tá tudo no UFRJ? Já estão voltando a...
Tá começando, né, voltar de forma presencial. No semestre que vem teremos uma parte, vamos dizer, das disciplinas experimentais que serão conduzidas de forma presencial ou híbrida, né? Então pelo menos vai ter uma pequena volta às atividades presenciais. Bom, vamos ver. Isso depende de nós até um certo ponto, porque a ocupação nas UTIs não depende dos professores da UFRJ, né? Então, vamos ver. Eu não sou muito otimista, porque está vindo para frente, estamos indo na direção do Réveillon, né? Depois vai vir Carnaval, então isso me preocupa um pouco do ponto de vista dos números da pandemia. Vamos ver. Sim. Vamos ver.
Natal e Carnaval no Brasil, em geral, é bem movimentado.
Bastante.
Aqui o UK está passando pelo primeiro teste pós-vacinação, né? A gente atingiu 80% das vacinações e o número de UTIs está se mantendo mais ou menos o mesmo. Então, aparentemente, a vacina está conseguindo controlar os casos. Pelo menos as internações.
É o que está acontecendo na Itália também. So let's go back to English.
It's okay. Unfortunately, I don't speak Portuguese or Brazilian.
It's one of the languages. Can teach you some, Martin.
Rodolfo can teach you.
Yeah, well,
yeah, absolutely.
Okay. I believe that when you're ready, Professor, we can...
I'm ready whenever you are.
Okay, so please, if you want to share your screen, I can begin. Our talk is already being streaming live, and as long as you share your screen, I will begin the recording of the session.
Okay, and so
okay.
Wait a minute.
Wonderful.
So, can you see my screen?
Yes. Could you please try to go in the presentation mode with the F5 button?
I am in the presentation mode, but perhaps it hasn't shown. I will try F5. What about that?
No, nothing changed. Maybe I don't know how to solve this problem.
Is that better?
No, it's not showing us the presentation mode. And
let me start again. I will stop sharing and try again. These things sometimes happen. Okay, I've now lost you.
Mm-hmm.
So can you see the screen now?
One moment. Yes, we can.
Is it now in the presentation mode?
No. One way to solve this issue may be to stop sharing your screen, sharing again as full screen.
Okay. So, okay, can you see my full screen now?
Yes. Yes. Okay.
Can you see the presentation?
Yes. Uh-huh. We can. Okay, now it's working.
And
wonderful.
okay.
We'll begin recording.
Can you see me?
Yes.
Okay.
Okay, so I will begin. Now the recording is in progress, and if you allow me, I will briefly introduce you.
Yes, yes.
So, good morning.
You can introduce me in Portuguese.
Ah, ok. Bem-vindos a todos e a todas. Bom dia para nós, né? Boa tarde para o Rodolfo, que está na Inglaterra, está em Nottingham. É um grande prazer para mim e para nós termos conosco hoje o professor Martyn Poliakoff, que vai dar uma palestra sobre o futuro profissional dos pesquisadores após do término do doutorado, né? Na palestra dele, ele terá intervenções também do Rodolfo Teixeira, que é um ex-aluno da Pós-Graduação em Química do UFRJ, que agora está conduzindo um projeto de pós-doutorado na Universidade de Nottingham, sob a orientação do professor Poliakoff. Sobre química em fluxo, química verde em fluxo, se não estou errado. É um grande prazer ter o professor Martyn Poliakoff conosco. O professor Poliakoff é talvez o palestrante de maior relevância do nosso ciclo de seminários desse semestre, que se conclui com o professor Martyn Poliakoff. É um dos poucos convidados desse ciclo que possui uma página Wikipedia. Então, isso já dá para termos uma ideia sobre a relevância do professor. Chamar ele de professor não é o título correto para chamá-lo, né? Porque ele é Sir, ele é cavaleiro da inglês, né? Pelos méritos científicos dele. Então, eu vou fazer aqui um brevíssimo resumo da atividade profissional dele. O professor Sir Martyn Poliakoff, ele se formou no King's College em Cambridge, no Reino Unido, né, em 1969, e obteve o doutorado dele em 1973. Agora ele é professor na Universidade de Nottingham, no Reino Unido, onde ele, além das aulas, né, sobre Química Verde, Green Chemistry, ele trabalha tem uma atividade de pesquisa, um grupo de pesquisa muito forte que trabalha na área de Green Chemistry, de espectroscopia e de espectroscopia. O professor Poliakoff é conhecido também pela atividade de grande sucesso de divulgação científica. Ele pertence à equipe responsável do canal YouTube Periodic Videos, onde eles apresentam vídeos sobre química dos elementos. Essa atividade começou no final de 2000 e continua desde então, né? O canal Periodic Videos, ele tem algo do tipo de 1,5 milhão de inscritos, né? Vou aqui resumir muito rapidamente as honras e os prêmios do professor, né? O professor ele foi homenageado com a Meldola Medal, né? Prêmio pela Royal Society in Chemistry em 1976. Desde 2002 ele foi eleito Fellow of the Royal Society. E em 2002 também foi eleito Fellow da Royal Society of Chemistry. E em 2004 Fellow of the Institution of Chemical Engineers. Ele foi nomeado Cavaleiro da Ordem do Império Britânico, né, em 2008. E também ele desde 2008 é um membro honorário da Academia da Química da Etiópia e um membro estrangeiro da Academia Russa das Ciências desde 2011. Em 2011 também ele ganhou o prêmio Nyholm para a educação científica. E entre as outras prêmios que ele ganhou tem a medalha Leverhulme pelas contribuições dele na química verde e a utilização dos fluidos supercríticos. O prêmio Michael Faraday pela divulgação científica através do canal do YouTube Periodic Videos, e o prêmio Lecture UK Canada Rutherford Lecture pela catálise multifase com os fluidos supercríticos. Ele também recebeu um doutorado honorário, né, pela Heriot-Watt University em 2011. Então eu espero de ter well, I will switch to English now. I hope I gave you a brief review of the scientific width of the speaker of today. It's such a pleasure to have you with us, Professor Sir Poliakoff, and please, I'm very glad to leave the room, the floor to you. Thank you very much.
Well, thank you very much, Giordano. Your introduction was very good, but much too long. And so I hope that you will not expect too much from me after such a long introduction. So my talk, the title is After Your PhD, What Then? And I'm Martin. And we have on this call our postdoc, Rodolfo, who graduated from your university and joined us in Nottingham a few months ago. And he will be here to translate things if you can't understand them, or help you to ask me questions. And I'm not sure whether you have a chat function on this program, but if you do, please put questions on the chat as we go along. And so we begin with some questions that you might ask. And the first one is, why am I, that's you, doing a PhD? And the next question is, what should I do next after your PhD? And then what will I be doing in 5 years' time? Perhaps in 10 years' time? And what about 52 years' time? The reason I have chosen 52 years, because that is the time since I started my PhD. So I would not have dreamt that I was doing any of the things that I'm doing now when I started my PhD. So you've heard a lot about me already, but if I can summarize, my title is Research Professor in Chemistry, and I'm working in the area of green chemistry. I'll explain what that is. I was born in London in 1947, so at Christmas time I'll be 74 years old, and my father was Russian, was born in Moscow, and Russia has been quite important in my career, though I'm not going to talk about that much today. As you heard, I studied in Cambridge. I worked in the Newcastle upon Tyne. I'll tell you a bit about that. And I've been at Nottingham since 1979. And as Giordano said, I was a student at King's College, Cambridge. This is King's College. And I think in my whole career, I went in about like this once or perhaps twice. And when I was at the college and finishing my undergraduate career degree, I went to see my tutor, who was Giordano, who was from Italy, who was an economist called Mario Nuti. And he said to me, when you're young, choosing a research topic is like falling in love. There are many possibilities. And in my case, in my first week at university, I met Dr. Jim Turner, and he taught me chemistry as an undergraduate. And I decided to carry out my PhD with him. Also in my first week, I met Janet, who became my girlfriend and then my wife. And we were married just before the start of my PhD. Here you can see us see Janet on our wedding day. And very fortunately, her father here, John Keane, was an extremely good experimental scientist. And I learned quite a lot from him during my PhD. It was almost like having a second supervisor. So, why do you do a PhD? And the reason you do a PhD, in my view, you may not agree, is to learn to solve problems. So, I'm going to make most of this lecture about the work that I've done and my experience. Part of the reason for this is that I can be rude about myself. I can say bad things about myself, but I can only be polite about other people. So, my PhD, to explain it very simply, is that if you take some sort of chemical or reaction, you can see what the starting material is, and you can see what the reaction products are. But in a normal chemical reaction, you cannot work out what happens, how the starting material gets to the product. So in this particular case of the egg sitting on the wall and falling off, there are three possible mechanisms. You can have what chemists call an excited state, and he falls off, or a relaxation process here, he falls off, and alternatively you can have what is known as energy transfer, energy coming from here and causing the problem. So if you want to know what happens during a chemical reaction, how it occurs, you have to have some way of looking at this intermediate stage. Nowadays, these are done with lasers and things like that. But when I started my PhD, lasers had only just been invented and nobody knew what to use them for. So I used a rather different technique. I didn't invent it, I was taught it, which is called matrix isolation, where you slow down the behavior of reactive molecules by immobilizing them in a solid at a low temperature. So the reactive molecules are a bit like these cars stuck in the snow. I know snow is difficult for people in Brazil to imagine. It doesn't snow in here, but you can imagine when it's cold, things don't work. And this shows the apparatus that I used with my PhD. And here, this purple color was obtained by taking this molecule called chromium hexacarbonyl, frozen in solid argon at 20 degrees absolute, and irradiating it with UV light. So here, this ring is perhaps a couple of centimeters across. This is at 20 degrees absolute, minus 253 degrees centigrade. This is a vacuum jacket, and you can study the things by infrared spectroscopy. So you can see it was quite a specialized technique. And I should have said that when I was a student, an undergraduate, I got really worried before my final examinations. And so I very nearly failed. I got a terrible degree. So I was quite worried how I would get a job after my PhD, because I didn't have first-class degrees and things like that. But then a miracle happened. In my third year of my PhD, Jim became a professor in Newcastle upon Tyne in the northeast of England, and he gave me a job without an interview, and I became a research officer and moved to University of Newcastle upon Tyne with him. And here is a picture of the inorganic chemistry staff 2 years later. Here is Jim Turner, my supervisor, and you can probably see me there. And there's technicians there, and the secretary. So you can see it's quite a small group, and all of the rest of these people here are members of staff. And importantly, sitting next to me was this man here, Alec Campbell, who taught me how to teach. It's really important, if you're going to work at university, that you should learn how to teach. And nowadays there are all sorts of courses, but when I was young there weren't any courses, but Alec gave me a lot of help, and I'm really grateful to him. And you can see my hair has changed in color, but not in structure very much. So then Jim moved to Nottingham in 1979. He became a professor, and I got a job, a lectureship, and moved with him. In Newcastle, I didn't have an interview to get the job. To go to Nottingham, I had to have an interview, but I was the only candidate, so the competition was not very strong. So here's a picture of our group in 1988. That's 9 years after we moved. And there are several points to make out. Here is Jim Turner, my supervisor, now professor. And this is Mark, who's our was a technician then and is still a senior technician in Nottingham. And here's one of my students, Mike George, who is now leader of our research group and effectively my boss. And behind him is a postdoc, Steve Howdell, who's now the head of our School of Chemistry. So these two are my bosses at the university. The other thing I want you to see is that there is only one woman in this whole group. And things have changed. So this is a photo that was taken somewhat later in 2003. That's 18 years ago. And in the middle, labeled 3, there's me. And next to me is my PhD supervisor, Jim Turner. And on the other side is Norman Shepherd, who was Jim's PhD supervisor. And over here is Mike George, who was my PhD student. And finally, this is Swejung Sun, who was Mike's PhD student. So you can see we have 5 generations beginning with Norman Shepherd, 2, 3, 4, 5 generations, like a big family. And in fact, you can look at my family tree. You can see here's me, then going back, my scientific father, my scientific grandfather. And you can go even further. So here they are again. You can see his supervisor and then his supervisor. And it can go back to Friedrich Wöhler, who discovered the element yttrium and did a fundamental experiment with organic chemistry. And you can go right back to Berzelius, who was the person who invented the words catalysis and organic chemistry and discovered 4 different elements. So you can see there is a family tree going all the way back to these founding chemists. And I'm sure the same is true for all of the professors and staff in your university. So Rodolfo or Giordano could trace a similar tree back. Sorry. So the next question that you might ask is that when you've finished your PhD, what should you do next? Because not everybody can become academics, become professors. Otherwise, the whole world would be full of professors. And you can't imagine anything worse than that. So I'm just going to give you a couple of examples. If we'd been in my office, I would have shown you this large lump of metal, which has got a hole in the middle, and you can stick a pencil through it to show the hole. And the point about this hole was that the hole was made using a 100-gram charge of explosives by one of my students who joined ICI Explosives, a big British explosives company, and a few months after he joined, he did a little demonstration for me, made this hole through the piece of metal. And this is the student, John McLaughlin, who was a PhD student with me and Jim Turner, started 41 years ago. And recently, when I made this slide, it was 7 years ago, John was the senior vice president of Orica, which is one of the world's biggest explosive companies. And I emailed him and he replied, "I'm coming down from a bit of a business high, having just delivered the biggest deal of our company's ever done, just under $3 billion. So you can see you can do a PhD and then become a really successful industrialist. Another student was Amanda Horton-Mastin. Giordano, she was half Italian. You can see from her hair, perhaps. And she did a PhD called Matrix Photochemistry of Organometallic Intermediates. You can see this is the title page, and here's her PhD thesis. So 30 years on, what was she doing? She was Director of Innovation at a charity called Comic Relief. Comic Relief is a big charity in the UK which collects money once a year by making people wear red noses, like a clown. And a few years ago, I think 7 or 8 years ago, they had the first Red Nose Day in the United States, which Amanda launched. And in one day, she collected $10 million for charity. So you can see a PhD in low temperature infrared spectroscopy can result in you becoming somebody who can raise millions of dollars for charity to help the poor of the world. So how does this all apply to me? And what I want to emphasize is the complete role of chance in my career, and I think in most people's career. And in my case, one of the big pieces of chance was that this woman, Veronica Vida, who's a professor in Boulder, Colorado, came to visit Nottingham in January 1985, and she brought a high-pressure cell for studying infrared spectroscopy to Nottingham. And she came for one day, but she left the cell behind. And that cell completely changed my research, because I started studying a new topic, supercritical fluids, highly compressed gases that can be used as chemical solvents. And, this also led to me becoming involved with green chemistry, which are cleaner approaches to making chemicals and materials. The idea of green chemistry is that you do something in the lab and try and produce a greener process and then transfer this to industry. And my particular area of interest were cleaner solvents, replacing toxic solvents with compressed gases such as carbon dioxide. And my big break in this area came when an article was published in a journal called New Scientist, which is a very popular journal in the UK, a bit like Scientific American, except it comes out each week. And there was an article about supercritical fluids, which included an account of some of our work. I was really a bit cross. I felt didn't say things that were nice enough about our work. But this article had a huge effect on me, because it was read by this gentleman here called Thomas Swan, who at that time was the owner of the second largest private chemical company in the UK called Thomas Swan & Co. Limited. And he read the article, he was excited by what my research group was doing, and he said he wanted to collaborate. And he wanted to collaborate after some discussion on supercritical hydrogenation. This is adding hydrogen to organic compounds. The idea is that you take the substrate, the organic compound you want to hydrogenate, and hydrogen, you mix them with high pressure CO2, you pass them through a reactor containing a catalyst. The substrate turns to product, and you release the pressure, and the carbon dioxide goes this way and the product goes that way. So I don't know if you can see, I've got a small reactor here. It's just a metal tube. You can see, you can put a pencil through it to show it's just a tube, and you put a catalyst in this. But with a tube this size, we could produce the equivalent of 7 tons of product in a year. And the Thomas Swan took this technology and built a full-scale 1,000 tons a year supercritical plant. And here you can see part of the plant, and this is my student Fiona Smale, who then went on to work for the company, and my wife Janet, the one you saw in the photo but on our wedding day, who is a mathematician but came to see the chemical plant. And so I was really quite proud to show my wife the chemical plant that we had built. And the actual reaction that we did commercially was the hydrogenation of this molecule here called isophorone to make trimethyl cyclohexanone, TMCH. And the plant could do this on about 1,000 tons a year scale. And this was the first bottle of the compound that was made, which was given to me. And you can see it says batch 1. So, shortly after the chemical plant opened, our son Simon decided that he would like to resign from his job in industry in the UK and go and teach physics in Ethiopia as a volunteer physics teacher. And here you can see Simon standing outside his school in a town called Hosanna, which is about 200 kilometers from the capital. And at that time, he was the only European in this town of about 40,000 people. And my wife and I visited him, and I was invited to give the first green chemistry lecture in Ethiopia at his school. And here you can see the audience. And he said that if it rained, we wouldn't be able to have the lecture because the rain would make too much noise on the roof. And the rain in Ethiopia is a bit like the rain in Brazil. It comes down very hard when it rains. And so many people wanted to come to the lecture that the doors had to be locked. And it is the only time in my life that I have lectured where people were looking through the windows from the outside, looking into the lecture theatre. I've often lectured in rooms where people are looking out of the window when I'm lecturing because they're bored, but it was the first time anybody had looked in. And here you can see me in my African outfit as professor, and quite amusingly, my wife complained when she saw me lecturing that my trousers looked rather short. They weren't long enough. And the next day we were packing up our clothes to move to the next place on our tour, and Janet said, "Where are my trousers?" And we couldn't find them, and then I suddenly realized I was wearing my wife's trousers. I'd put on the wrong clothes. So the first lecture on green chemistry in Ethiopia was given by me wearing my wife's trousers. But the teachers really liked the lecture and said we should visit the university in the capital. We visited the university. We met this woman here, Dr. Nigist. She became very interested in green chemistry. She visited Nottingham, and 2 years later, she went to a conference in Washington where she met the founder of green chemistry, Paul Anastas. And then 2 years after that, Nottingham and Addis Ababa University organized a green chemistry workshop in the town of Jimma, which is in the center of the coffee growing region of Ethiopia. And you can see here our conference bus. And then in 2013, the Deputy Prime Minister of Ethiopia came to visit our laboratory in Nottingham. Here you can see His Excellency Demeke with two of our Ethiopian students who were there at the time, Bitu and Andanet. And so we really made quite an impression on chemistry in Ethiopia. So now I want to tell you about a life-changing event for me. The thing about life-changing events, unless it's some terrible accident, is that you don't really realize how important something might be until long after it happened. And in my case, it was a visit by the EPSRC, which is the UK National Funding Council, Engineering and Physical Sciences Research Council, and they announced they were coming to visit Nottingham. And I thought it was a great opportunity to find out how to get more money for our research. But then I got an email from the senior administrator saying they wanted me to go to a meeting on corporate communication. And you can never resist senior administrators in your university. So I registered for this workshop, and they said they looked forward to seeing us. And at this workshop, the university showed a short video about a YouTube website. YouTube had just begun about 18 months beforehand. And these were videos about scientists working in Nottingham doing science. And I got really excited by these videos. And I sent an email to the organizer called Jonathan Ray saying, I'm really impressed by test tube. I've spent most of the afternoon telling my colleagues and students about it. Well done. And the result of this was, of course, that I was invited to make YouTube videos. And so Brady Harron, the video maker who'd made these videos, came to my office, and we made several videos. One of the first was me talking about supercritical fluids. And in the early days, we got quite excited when it had been watched by 7,000 views. This has now been watched by more than 300,000 people. And I made, I think, 8 videos on that day, all very short. And a few weeks later, Brady came to me and said he would like to make one video about each element on the periodic table. And I told him he was mad, because at that time, for example, there was no atoms of element 117 had ever been made or observed. So how could you make a video about an element that didn't exist? But he persuaded me that we should do it. And so we started making videos, and we made 118 videos. And if you click, say, on hydrogen, you get a video about hydrogen. Here's my colleague Pete, and you can see he blew up big balloon of hydrogen. And we've now continued making them. I didn't understand the number of views and things that Giordano said in Brazilian, but we've now got more than 260 million views for our videos and more than 1.5 million subscribers. We even won a prize from the journal Science, which allowed us to publish an article about our videos in Science. So Brady, our video maker who has no scientific qualifications, has got a paper in Science, a paper in Nature Chemistry, and another one in Angewandte Chemie. So he is a very distinguished, published person. And it allows me to travel. Here's me sitting on Copacabana Beach. I believe perhaps I'm the only person who's ever sat on the beach wearing a periodic table tie. And although you may not realize it, this was actually a video about the element xenon, because somebody had recently published a paper which said that they thought that much of the world's xenon was actually trapped as individual atoms in silica around the planet, and therefore there might be quite a lot of trapped xenon on the beach. And we made another video on the Corcovado, and I perhaps is one of the few people who has actually demonstrated that the stone on the statue is the same material that is used in baby powder. And I have a bottle here of baby powder, and it's largely magnesium sulfate. So in July 2011, shortly after we made these videos, I was elected the so-called Foreign Secretary of the Royal Society. The Royal Society which was founded in 1660, is the world's oldest continuously operating Academy of Science. It's like the Brazilian Academy of Science, but very much older. And it was, there are 5 officers, the president and 4 vice presidents, and I was one of them. And there are about 1,500 fellows and foreign members. And although it's a national academy, it is independent of the UK government. And it was founded by King Charles II, who, particularly in the context of Brazil, is interesting because he's the only English king who married a Portuguese wife. And he married Catherine of Braganza, who you can see here. His marriage was not meant to be very successful because he couldn't speak Portuguese and she couldn't speak English. And so they didn't have children, though he had many other children by other women. Now, the role of the Foreign Secretary, the job that I was doing, was defined in 1663 as to enjoy mutual intelligence and affairs with all manner of strangers and foreigners, which really means that I had to be a sort of ambassador for UK science. And I traveled all over the world, meeting people and acting as a representative for UK science. It's really the only big administrative role I've ever had during my career. And so, for example, here during the meeting of the G7 in Berlin, I met Angela Merkel. It was a brief meeting, and we did little more than shake hands. As you probably know, that Angela Merkel is, I think, a physicist, and her husband is a very distinguished theoretical chemist. I finished in 2016, but until the pandemic, I still did quite a lot of traveling. And in January 2020, I received a prize in China. And here you can see me shaking hands with Xi Jinping, the president of China. Our conversation was slightly limited because I don't speak Chinese and he doesn't speak English, though he did get quite excited by my periodic table Tai, which was in Chinese. So, my guiding principle for all my scientific collaborations, whether it's been with industry or with scientists in other countries, has been that one should never collaborate or work with someone you don't like from the beginning, because things can only get worse. So if you don't like somebody, it isn't going to work out. So, now some questions for you. These are not questions I'm going to answer, but they're questions that you've got to think about. The first thing is, what do you think, I think, that means you, I want to do in the long term? And then, what is a sensible next stage in my career towards this goal? And what sort of people do I need to guide me? And how do I start looking for them? So when I first prepared this lecture in 2008, I wondered what my tutor, Mario Nuti, thought 40 years after he'd given me the advice that research was like falling in love. So I Googled him. It was in the early days of Google, and I emailed him and he replied. And he said, in principle, there are millions of partners or topics with which one can be happy. But chance encounters, chance meetings and their developments make one person or topic unique and irreplaceable, unleashing commitment and involvement. And it's reciprocal too. Topics repay loving attachment with research results. And 9 years later, I asked him again if he'd changed his mind. I was now Sir, so he wrote, "My dear Sir Martyn, cheer up, I can assure you that there is life after 70, indeed after 80, which I reached 2 months ago." And then he put a quotation from one of his friends. "People used to be much healthier when they lived less long. Have a good time and warmest good wishes, yours as ever, Mario." So when I was preparing this lecture, I thought I would email him again. And sadly, I discovered that he died at Christmas. But there was a nice obituary appreciation of his career saying, "Mario has left behind much more than his valuable scientific contributions. He was an intellectual of a special kind, with a critical mind and great knowledge in many fields that extend far beyond economics." He was an economist. "He remained consistent in his views until his very last days." So, my final comment from somebody is from the Nobel laureate, Nobel Prize winner Barry Sharpless, who won the Chemistry Nobel Prize, saying, "People who worry about missing opportunities never get anywhere. They're too frightened to discover anything." So the take-home message from this talk for you is, don't worry. The future is yours. Enjoy your work and you'll succeed. So finally, I just need to thank my co-workers, colleagues, collaborators, our technicians, and the funders who the past and the present. With the lockdown, we haven't been able to take a group photograph for 2 years. So this is our picture from 2019. And what I hope you can see is that this is a very much more diverse group than it was in 1988, with many more women and people from all over the world. And we always welcome intelligent, capable researchers like Rodolfo to work with us in Nottingham. Thank you. Now it's your turn to ask me some questions.
Thank you very much, Professor, for this very inspiring talk, and it's been fun as well in some places. Thank you very much. Thank you very much. Really.
I hope I've now stopped sharing. Yeah.
Yeah, you did.
So there's some questions.
When you got too many choices, it's hard to pick one. And yes, the future is ours. I believe this as well. Thank you very much for this very positive message. We now used to open the floor for interaction with the speaker. So let's see. There are some questions. Guilherme was the first one, I believe.
Oi, Jordan.
Okay. Could you please open your camera, if possible?
Let me try.
Professor, can you see us?
I can see us. Yes, I
Well,
can see
okay.
Guilherme. Hello. Oh, you've gone away.
Hello.
again.
Tudo bem, Guilherme?
Tudo bom.
So do ask your question. And if
Okay.
you want,
I can speak in English.
Yeah.
Hi, Professor. Thanks for the talk. I have a curiosity. You talked about the importance of knowing how to teach. With that in mind, what can be told about trying to teach or show that green subject matters to people that don't want to learn or listen?
well, I mean, there is a limit if people don't want to learn or listen. Fortunately, well, certainly if you're teaching at university level, most people who are studying, say, chemistry at university level want to study chemistry because they have chosen to study it. When they're at school, they may be that they have to study chemistry as well as lots of other subjects, and really they want to study history, but they've been told to study chemistry. I think the most important thing is to be really enthusiastic when you're teaching, because if you're bored about a subject as a teacher, how can you expect your students to be interested? And when I was teaching inorganic chemistry mechanisms some years ago, I was teaching something that I've always considered very boring. Substitution reactions in cobalt 3+ complexes. But suddenly the class was really quiet. And I thought, gosh, they're interested in this. I must be a bit more excited. And I got so excited about this topic that I couldn't do anything for the rest of the morning. So I think what's important is to be enthusiastic.
Okay, thanks.
A very good question, thank you.
Thank you.
Gabriel?
Hello, can you hear me?
Yes,
Can you see me?
yes, I can see you too.
Thank you very much for the talk, Professor. I have a question about how can we balance our choices between what is given to us as opportunities and what we must seek out due to our preferences in career? Because sometimes we have some opportunities present to us, but we don't really want to go, but they are there and don't know which path to take.
Well, I think in general, you have to take the opportunities that are there, because otherwise you will get nowhere. But you can find, usually, even if something is not quite what you want to do, that once you start doing it, you can often alter the direction of the work and tailor it more to what you want to do. When I was starting my PhD, my supervisor had two projects. One which was on halogen oxides, oxides of chlorine, bromine, and so on, and one on metal carbonyl chemistry. And I really wanted to do the halogen oxides, but he persuaded me that actually the metal carbonyls might be better. And I worked with the metal carbonyls for more than 30 years. But so I think sometimes you need to be guided, and solving research problems is a bit like solving some sort of puzzle in the newspaper. You do it because you're interested in the intellectual challenge. And if you look at the crosswords in the newspaper, Rodolfo, I don't know what crossword is in...
Palavras cruzadas.
Yes. If you look at the crossword, you don't actually care what the answers are. You just want to solve them, the excitement of solving it. And to some extent, solving some chemical problems is the same.
Okay, thank you very much.
Okay, so João.
Hello, can you hear me?
Yeah.
Yes?
Hi, Professor. Hi, Rodolfo. Professor, you said in your lecture that your tutor, Mario Nucci, told you about the falling in love with some research topic. Is it possible, if in case we fall in love with many topics over our lives, is it possible to conciliate the love for them? Can we work with many things we start falling in love, or do we have to abandon some?
I think the answer is it is probably easier to fall in love with many topics than it is to fall in love with many people. At least it is less complicated. I think in order to make a real contribution to science, you probably have to limit the number of areas. There is a famous scientist. I just have to find the picture. Yeah. I don't know if you can see this picture here. This man called Thomas Young, who was also Foreign Secretary of the Royal Society at the beginning of the 19th century. Thomas Young was a doctor, but also he did fundamental experiments with light. You may have remembered there's a thing called Young's slits for diffraction of light.
Yes.
He also discovered Young's modulus for stretching of springs. And in his spare time, he was the first person to translate Egyptian hieroglyphics. So, and you can see the book about him is called The Last Man Who Knew Everything. So there are a few people who can do that, but people like me, and perhaps like you, probably have to be slightly less ambitious. But I think that there is no reason why you shouldn't change your areas. I began as a mechanistic inorganic chemist. I still teach inorganic chemistry, but my research now is mostly in organic process chemistry, and I worked in in physical chemistry, and occasionally almost in physics. So I think you can move around.
Okay, thank you very much, Professor.
Thank you. Rafael.
Hi.
Hello.
Hello. My question it's about luck, and yeah, you said about like how many things happened in your life, and your research that were based on luck, but at the same time I feel like we should try to reach the things we want, right? So at each point, do you think that it is like luck has really I forgot the word, has like an importance on the path you may take on your life?
I think the answer is that it is probably not a good strategy to say, well, I'm not going to do anything, I shall just wait and hope I'm lucky, because that the French scientist Pasteur is quoted as saying that luck favors the prepared mind. So what you have to do is that if you're thinking about a problem, you may then see how one of the very well-known stories in science is about the biochemist Alexander Fleming, who discovered penicillin because some mold came through the window of his lab and started growing on the dish and killing the bacteria. But he had to have the prepared mind to realize the importance of what he was observing. So I think what I would say to you is that, of course, you must try and plan things, but if you see a lucky chance, you should not ignore it, but you should follow it.
Okay.
My father used to say that our family motto, the sort of family principle, should be, it is better to be lucky than efficient.
Okay, thank you.
Great motto. Great motto. Thank you. Beatriz.
Hi guys. Hi,
Hello.
Professor Martyn. So I'm thinking a lot what I'm going to do after take my PhD is something that I plan years and study what I want, what I am in love for my research. But sometimes can be a little frustrating when you plan too much for something but you don't succeed. And in Brazil, you have a lot of competition to get a position in a university, like as a teacher. So it's something that I feel a little afraid to try and whatever. And sometimes I'm thinking about what can do if I enforce some really difficult in this path. So I'm thinking what advice you can give to us. Sometimes it can let us frustrating, but you need to move on. What kind of advice?
So, well, the first thing I would say is that if you take my example, I did very badly in my examinations, and I also graduated at a time when it was just after there had been a big hiring of chemistry staff at universities across the UK. So there were lots of younger researchers, so there were not many openings. And so on the face of it, I was starting at a very unpromising time, but somehow I managed to do it. I think nowadays there are much bigger opportunities than when I was young to travel to other countries to do postdocs, and I think in Europe in general there is quite a shortage of good people to do postdoctoral positions. So perhaps Rodolfo, you would like to say something, because you have just been through this stage quite recently.
Well,
you can say it in Portuguese if you want.
O que eu posso te falar é que, tipo, o medo não ajuda, certo? Aparecem várias oportunidades que algumas vezes você fica até com medo de você aplicar para aquela vaga ou para aquela posição, porque você não se acha qualificado o suficiente ou você não acha que vai conseguir. A minha sugestão é: tenta. Porque o máximo vai acontecer você não conseguir. Se você não aplicasse, você também não conseguiria. Uma coisa que é muito comum é que a gente no Brasil muitas vezes se acha muito menos qualificado do que pessoas no exterior. E isso não é uma verdade. A gente é muito bem formado, tá bom? Então, a gente acaba, algumas vezes, até tendo algum destaque em relação, por exemplo, a nossa experiência em laboratório com iniciação científica, que é uma coisa que não existe aqui. E isso é muito bem visto. Tempo de laboratório, saber fazer as coisas no laboratório também é muito bem visto.
So, I'm sorry, I didn't understand the word that Rodrigo said, except I did understand at one point he said, for example. But I think the other point to say to Beatrice is that there are opportunities to go into industry and then to go back to universities. So you don't have to just think about going to university straight away. And I think it's also important to say that that teaching at high schools can also be very rewarding. My son has after he was in Ethiopia, he decided to become a professional teacher, and he's been teaching ever since. And I have been stopped in the railway stations by people saying, "Your son taught me physics, he was really good." So I think there is no point in being pessimistic. You cannot change the situation, but you can look at things in different ways. Think about traveling to another country, think about going into industry or whatever. Does that help?
Yeah, thank you.
Thank you, Beatrice. Yeah, we can overcome problems. And Professor, we have a question from the audience of the YouTube channel. Yeah. And first of all, Anna, she would like to thank you and congratulate with you for your excellent talk. And she's on this line as well. She's remarking that in Brazil we have a problem about research funding. Okay, so research funding has been better in Brazil, and now it's a bit of the money has been cut a lot. So how would you think? What advice would you give to future researchers who would like to collaborate with the country? I mean, I believe she's working at the university, but they have to cope with these frustrations about the funding.
Well, I think funding is always a frustration, and you have to remember that some research is much more expensive than others. If you are studying gold chemistry, you need much more money than if you're studying sodium chemistry, for example. There are companies that you may well be able to get some research funding from companies. A few years ago, I and my colleague Mike had a research collaboration with the Brazilian mining company CBMM for studying niobium chemistry. And so I think the first thing to do is to decide what you want to do, Anna, and then think how you might be able to get money for it. It is certainly possible to find organizations outside your own country that will fund research. I have had research funding during my career from Germany, from the United States, and from international companies as well.
Thank you, Professor.
Okay.
Okay. Rafael, I believe you forgot to lower your hand, so we have a question.
We may have another question.
Yes, thank you, Professor. From Gabriel. Gabriel, pode falar.
Okay, can you see me?
No, but I can hear you.
Yeah. Thank you, Professor, for your talk. It was amazing to get to know your story. But I started my PhD this year, and sometimes I think about all these questions of what I could do after finish it, or even during this part of my studies, because here in Brazil we have a big problem with research and funding, as it's already been told. And what I really would like to ask is if you could give us a hint about how to maintain our dream, our persistence during the PhD, and how to prepare for what is next when lack opportunities, you know. Actually, I also would like to know about Rodolfo and how did you get there? How did you do it?
So, well, let me first of all say, I think it would be very sad if you spend the whole of your PhD worrying about future funding, because if you think back when you were a child, you were probably not worrying about how much you would earn when you were an adult, but you were enjoying being a child. And I think one of the things about doing a PhD, it is an opportunity to enjoy science without some of the problems that you have when you're an older adult. You don't have to worry about most people as PhD students don't have to worry about their children or buying houses and all sorts of things that worry older people. But the thing is that funding of research depends on governments, and governments change, because even the longest lived politicians rarely last more than 10 years and often less, which is about 2 PhDs worth. So things will change. And Brazil is inherently a very rich country in terms of its natural resources. You've only got to think about the Brazil wood, Brazil, and how it made your country. So I think you have to stay optimistic. But now Rodrigo will give you the official answer.
Bem, eu concordo com o Martyn. Eu acho que o doutorado você tem que se preocupar mais em aprender. Certo? Eu sei que a gente passa dificuldade no Brasil. Eu sei que às vezes você não tem reagente para fazer as reações que você precisa. Muitas vezes a gente precisa preparar um material de partida que vai levar 10 etapas e a gente vai ter 10% de rendimento só para começar a fazer a pesquisa. Mas o que você tem que levar disso tudo é o que você aprende, porque é o que importa no final. Como o Martyn falou na apresentação dele, o doutorado em si é para você aprender a fazer pesquisa. Certo? Essa é o maior aprendizado que você traz do seu doutorado. Como resolver problemas. E isso você aprende independente de você ter todos os reagentes à sua disposição para começar diretamente o que você quer fazer, ou se você vai ter dificuldades e ter que preparar para fazer tudo. Na verdade, eu acho que a segunda situação acaba te preparando ainda melhor para enfrentar e desenvolver pesquisa. Então, em relação a isso, eu acho que essa tem que ser a sua motivação. A sua motivação, quando você está fazendo um doutorado, tem que ser aprender. Em relação a o que acontece em seguida, né, você pode começar a se preocupar isso quando você estiver mais perto do final. E assim, se você está aprendendo e você sabe as áreas que você quer seguir, você não precisa achar uma posição com uma vaga totalmente específica para o que você está fazendo. Você tem seus interesses, você tem suas grandes áreas de interesse, você sempre pode buscar coisas nessas regiões que você tem interesse, não necessariamente que é a sua maior área de expertise. E, em último caso, a indústria. Principalmente aqui fora, a indústria contrata muito.
Obrigado, Rodolfo. Thank you, Professor.
So I would just say that you, as a group of students, are very lucky to have Giordano, because he comes from a completely different country. And so you can ask him, why did he move? How are things different in Italy? And what are the advantages and disadvantages of moving from different countries? And my experience is that during my career, there have been periods where we have had a lot of people coming from a particular country. In the middle of the 1990s, we had 6 German postdocs in our research group because there were no jobs for chemists in Germany. But now we've had almost no applications from Germany because there are much better job opportunities there than they were. And then there was another time when it was almost a qualification in my research group that you had to speak Spanish as a postdoc because much of the research was done in Spanish. But, and we've had also quite a large number of people from China and so on. So, Giordano, are there more questions?
No, I believe that we have finished the questions. I would like your opinion on one point, if possible.
Yeah.
Since you have this very successful YouTube channel, it's not, I mean, you participate in it and you got this experience for divulgation of chemistry. I believe we are living in a time which is very strange because we have to convince people of the value of science. It's a bit of, I find it quite strange, okay? And how can you spread knowledge without hurting people's feelings and convincing them that what you're trying to tell them, it's the truth and it's not your personal opinion, and you don't want to harm them with the things you're explaining. I mean, I believe, how do you see this whole refusal of science and vaccine and something like that, which is happening at the moment in the world?
Well, I think, I mean, first of all, that resistance to science and so on is nothing new. And in the 18th century and 19th century, people smashed new machines because they felt they were removing jobs and so on. And I think it varies from one country to another. In some countries, science is very politicized. One party might say science is good, another party is very against science, which I believe, is the case in the United States. In the UK, that we are fortunate that most politicians seem very positive about science, but my experience of the communicating science through the internet is really how positive many people are about science. There have been occasions where I've made videos about topics that I think are a bit boring, like atomic weights. IUPAC changed the values of atomic weights of a few elements because depending which deposit you take from the ground, the atomic weight varies slightly because the isotopes are in different ratios. And I had to record that video 3 times till I was sufficiently excited. And a couple of weeks later, I was in South Africa and a woman came up to me and said, "Your video about atomic weights was wonderful." So I was really quite surprised. And I think it is really very encouraging how many people are enthusiastic about science. And I think it is also encouraging that over the last few years, that in topics like climate change, the number of people who have now arguing against the existence of climate change are getting smaller and smaller. So I think the signs are quite encouraging. But to answer your question, is that you have to be enthusiastic, you have to talk to people sensibly and not get angry with them, because as soon as you get a confrontation, they will fight back.
Yeah, that's the good take-home message.
So I wanted to say one really quite important thing to all the young people. Well, you're young too, Giordano. I think it's really important to say to you that if you look at somebody like me who is a professor, you may think that I'm really clever because I'm a professor compared to you who are still students. But this is not true. You are students because you're young, and I'm a professor because I'm old, not because I'm clever and you're stupid. And I'm sure that there are several of you who are listening who are much cleverer than me. So you've still got a lot to learn, but you should remember that you are quite as clever as the people who teach you, and probably cleverer than some of them.
I don't know if that's true, but yeah, okay. Thank you for the message.
I'm sure it's true. And I wish you all terrific success with your research.
Thank you very
and
much.
Perhaps we may see one or two of you in Nottingham.
Would be lovely. Would be lovely, Professor. Thank you. So I would like to thank you very much for your time and your enthusiasm. And the take-home message of the final seminar of our semester is be enthusiastic and channel this enthusiasm in your activity as a lecturer or as a researcher, and this will spread around us. Thank you very much. That was a lovely message. I'm very happy of your talk. Rodolfo, would you like to say something? I believe we have finished our questions now.
Just a final message as well. I think Martyn's right. You should be enthusiastic about everything, and well, something else, never stop learning. I think this is quite important as well.
Okay, thank you, Rodolfo. Yeah, most definitely. Learning is a luxury that not all of us have, and we have to treasure it. And so, if you allow me, I would like to ask the people, the students, to open their cameras and their microphones, to clap our hands, to say thank you very much, Sir Professor Martyn Poliakoff, for joining us and for giving us this very beautiful lecture. Thank you very much. I hope we can see ourselves again in Nottingham or in Copacabana. I don't know.
Thank you.
It would be lovely. Thank you very much, Professor. It's been a pleasure.
Thank you. So, goodbye.
Goodbye. Tchau, tchau. Obrigado a todos que apareceram no canal do YouTube também. Uma boa tarde a todos. Um abraço.
Obrigada, gente. Boa tarde.
Obrigado, tchau.
Tchau.
Boa tarde.
Tchau, gente.
Obrigada, boa tarde.
Obrigada, boa tarde. Tchau.
Boa tarde, tchau.
Boa tarde, tchau.